Okay, we're going to start looking at complex numbers, which are bigger than the set of real numbers that we're all used to working with. And we're going to begin by discussing the imaginary number I. Now, this word imaginary doesn't mean that the number I doesn't exist. It's just a name that we give to it. In fact, what is the number 2? Well, it's something we created, right? So the number 2 doesn't really exist. It's not a physical thing, but we created it to satisfy our personal needs as human beings. And the number I came from this idea that if you have a number squared and it equals a negative 1, then, what is the number x? Well, x is definitely not a real number, because if you multiply a real number by itself, you're going to get a positive number, and we've discussed this. So x is not a real number, so what we did was we created a number I such that I squared is negative 1. Okay, so what is the number I? Well, I is the square root of negative 1. Okay, so I is the square root of negative 1. We define it that way. That's the definition of this new number, which allows us to take square roots of negatives. Again, it's not a real number, it's a complex number. And then I squared is negative 1. So those are the two basic facts about I. Okay, so let's look at any other powers of I. I to the first is I squared, we already saw, is negative 1. And now, to get I cubed, I can multiply both sides of this by I, right? So if I do that, the left side's going to be I cubed, and the right side's going to be negative 1 times I, which is negative I. Similarly, if I continue this pattern, multiply both sides by I here, then the left side is going to give me I to the fourth, and the right side is going to give me negative I squared. But I squared is negative 1. So if I replace that, I squared with negative 1, I get negative 1, which is positive 1. So I to the fourth is positive 1. Let's continue. Multiply both sides by I. The left side is going to give me I to the fifth. The right side is going to give me 1 times I, which is I. So what we see here is we get a pattern, right? We've got the first 4 powers of I, and then I to the fifth, this pattern starts over, because now I to the fifth is the same thing as I to the first. You see that? So I to the sixth would be the same thing as I squared, because you just multiply both sides by I and you get the same thing. So this pattern just continues. It's a cyclic pattern that just repeats forever. So this is very nice because it allows us to find I to any power. We could reduce I to any power to either I or negative I, or negative 1 or positive 1. Okay, so let's get a handle on this. The way I like to look at it is, what I notice is I to the fourth is 1, I to the eighth, which would be down here, would be 1, I to the 12th, which would be down here, would be 1. So in general, I to an exponent that is a multiple of 4 is always 1. So I use that as my basic understanding of this pattern. Okay, so how would you use that then to figure out I to the 27th power? Well, you want to find the closest multiple of 4 to 27, which was 24. So I to the 24th is 1. That means I to the 25th, if you multiply both sides by I to the 25th would be 1 times I, which is I, and we're almost I to the 27th. I to the 26th would be multiplying both sides of the previous step by I times I is I squared, which is negative 1. And finally, I to the 27th, if you multiply both sides of the previous step here by I, you get negative I. So I to the 27th is negative I. Okay? And you can do this for any number, or any exponent. You can simply find the nearest multiple of 4 and then build up from there. There are other ways to do it as well. I'm going to focus on this method.